Hello everyone, welcome to another webinar hosted by Toradex. The title of today's webinar is Chaotic Field Management with Debian Devices, Not Anymore. Here we will talk a little bit about the current state of Debian, the state of Debian in production, at volume production, and what Torizon and Toradex are doing to help make that process a little bit easier. Just before we start, a few organizational things. First, the webinar is being recorded and it will be made available for later on-demand viewing. And also you see there a chat window. If you have any sort of technical issues, please share in there. Our team is monitoring it and they will be able to further assist you. And also if you have any questions, please drop them in the chat. At the end, we will have a Q&A session where we will take them and answer them. So introducing a little bit myself, I'm Lucas, I'm Product Marketing Manager here at Toradex, and here with me I have Drew, Technical Solutions Architect for Torizon. Hey Drew.
Hello, thanks everybody for joining.
Moving over to the agenda, as I was saying in the beginning, the idea is to start with a brief overview on the state-of-the-art Debian for embedded devices today in volume production, so it's thousands of devices of fleets. After we show how that works, we will show a little bit about our solutions, introduce also the Torizon ecosystem and how it connects with Debian. Drew has a very cool demo to share with us, and then some more advanced use cases like migrating existing fleets, also a little bit about Torizon OS as kind of the next step in the OS. This is more or less reflected on what we see on the industry. This is a recent survey, about 2 years old, made by Aspen Core Media for embedded.com, where you can see there that Ubuntu and Debian, so the most common desktop style distros, they make up about 1/3, 35% of considerations for new projects there in the next 12 months, so 2 years to 1 year ago. So it more or less reflects with the 25% that we see here in the webinar today, which is always good. And Drew, could you walk us through a little bit why people like to use Debian and Ubuntu for this sort of deployments?
Sure. The biggest answer is familiarity. Obviously, there's a lot of engineering talent out there with experience running Debian-style distros, and by that I mean anything based basically on the APT package manager. So that could be Debian, Ubuntu, or many other variants like that. The other thing is it's there's usually a large corpus of software already available in the public package feeds for these things, so it really gives you a leg up on developing your application. You're not starting completely from a blank page in the code editor. You've got a lot of software to start with. A lot of good wiki pages and websites that can help get you started really good there. Also, Debian is known to be a stable operating system. Where our example today is using Debian Trixie, which just came out, and they're not too quick about adopting the very latest things and that kind of thing. Ultimately it comes down to what are your developers familiar with, what do they already know how to do, and that's the primary reason we see that folks are using Debian. In a lot of cases, some our customers that are doing that, they actually start on an x86 PC, just something they had in the closet, or maybe even a more embedded form factor, and they grab the standard Debian ISO and install it and just start doing their work. So that's really kind of the way this happens in most cases, especially for those that are not deeply plugged into the embedded Linux, Yocto build root side of things, but they're getting started with a new embedded project. Debian is what they know.
Yeah, fair enough. It's very good to work with in a lab environment, right? So, for example, you develop. We see this especially talking about higher level applications like machine learning, AI, all of that hype, that recent hype. People develop their machine learning models on their PCs. With like the NVIDIA stuff, with all of the APT packages and all of that, and then they look for an easy way to embed it, which is of course as easy as it can get through Debian, right? Just APT install the things and run it. So very good for lab environments. How's the process then from the lab to an actual, deployment stage when you are no longer playing with one device, but you are looking at hundreds or thousands of devices in the field,
Yeah, and this is probably the first area of people that are working with these kind of distributions when they start to see some of the limitations of this. If you're familiar with the whole pets versus cattle argument that came mostly out of the enterprise server type things, it's a similar kind of thing, right? So typically, unless you spend a lot of time up front customizing scripts to make it so that you can build these systems in a more repeatable fashion. Usually what happens is, you install it on a board, you log into the board, apt install whatever you need. A lot of people these days are even installing the tools and building their actual application on the device. And then, when they're ready to go to production, then they have to strip out all the stuff they don't need and create the golden image. And, that golden image approach can work, but it doesn't scale well, right? If you're dealing with a team of developers, that golden image is kind of a global lock for the entire team, right? So as long as, if I'm making a change to the golden image, Lucas, you're sitting there and you can't do anything until I release it. Unless, like I say, unless you spend a lot of time developing tooling around things like the Bootstrap, and there's a number of image builders for Debian and various systems like that, but most of the time when we talk to people that are working with Debian, they have not gone that route, so they're stuck with that golden image. That golden image model. The other update, the other thing to consider is things like over-the-air updates. That's not something that's built into Debian. It has to be added on after the fact. Yes, they have the package-based updaters that can be utilized for that, but it's not, it doesn't really give you that dashboard view of your fleet and allow you to deploy updates and things like that. So it's quick to get started for your application development, but the management of the fleet of devices over the life of the product is something that you're going to have to end up doing a lot of work to add on if you don't have a third-party provider for it.
Yeah, and I think on the next slide we also mentioned a little bit more examples. So, for example, on the security side, there is a lot of talk regarding secure boots, which then makes it a little bit hard to work with. There's the whole issue with package drift. So as the sentence there goes, how do I add or update package X to my image after 2 years of not updating? This is very common, right? You have a fix that you see that you need, for example, so you need to update it, but then the requirements and dependencies cascades. Just by running apt upgrade, you end up with hundreds of packages, after 2 years of not upgrading it, that need to be upgraded, and then the chances of breaking something starts to increase. And these are few devices, these are production devices, which of course is something that we don't want them getting any sort of risk. Maintaining the secure package feed also is a lot of work. So if you have your application on your own Debian feed, package feed, you need to make sure that it's secure, that it's reliable, right? If apt cannot reach it, then it's no use in the end. So all of these ad hoc solutions, they increase time to market, they make it a little bit harder for your engineers to work with. Also increase a lot of risk because there's a lot of things that can go wrong. Increases dependency on community and open source. You need to make sure that people are updating the right type of thing, the kind of package that you need. They are backporting fixes and all of that. And in the end, customers end up with a little bit massive fleets there, which is when things get a little bit chaotic, right?
Yeah, for sure. And you mentioned immutability there. That's an important concept that really helps with the scalability, right? The idea is I know that every device is running the exact same set of files when I have an immutable operating system. Whereas if I have a package-based operating system and the system does an apt update at some point, it gets whatever version of packages are in the package feed at that exact moment. And if the next board in the list waits an hour or two, it might get a slightly different set of packages. So that immutability and the lack of package drift is what really is going to give you a lot of benefit over especially once you're in the maintenance phase and these things are out in the field. It's nice to have that immutability to guarantee that I know that what I've tested is exactly what my end users are using.
Yep. I think we had some content like that here. In the end, it's all, the worst case of all is when all of that happens together, and then you have field failures, but you don't know you have field failures because each board is running a specific version of a package that you might have updated them at different times, and you don't know what's running where, which version is running where. So your fleet begins to diverge in terms of versions and packages and all of the compliance processes and all of that, which is exactly what you don't want to happen, right?
Yeah, and I think it's important to note that the benefit of Debian and using something like that is you can get started and make progress very quickly at the expense of more complexity. You're pushing the complexity later in the process. And so it's when you're in maintenance mode and you've got a large number of devices in the field, that's where the complexity really starts to come in, or as this slide says, the chaos.
Keep going here. This whole management issue is not the only thing, right? With these deployed devices being increasingly more subject to cybersecurity regulations and being under more scrutiny in terms of security and in terms of reliability, even if they are not online, it gets even worse, this problem, right, with Debian. So for example, here we use the EU Cyber Resilience Act regulation as an example, just to give some background. This is something that's already entering into force. It has entered into force in December, so if you sell your products on the EU, the European Union, then you need to be compliant. It's already entered into force, but they gave like a 2-year grace period between quotes there to be fully compliant. There are some middle dates that are important. For example, September 2026, where the reporting obligations start to become mandatory. But yeah, just going over real quick here in terms of requirements, we split it there under these three main pillars. So product requirements, which is your standards, secure boots, making sure that the product is not has a reduced attack surface. It has some sort of update mechanism to mitigate vulnerabilities. Of course, it needs to be secure, it needs to be reliable. So this implies like rollback, all of the signed checks, all of the security stuff. Vulnerability handling, so the second pillar, you need to be able to look at your software, understand what components make up your software. So this is the software bill of materials in technical terms, which describes everything on your image, exactly what software you use, exactly what version you use, and you need to be able to monitor your software bill of materials to match it against known CVEs, against known exploits, and also make sure that you are not running anything that has actively exploited vulnerabilities in the field. In case you do, you also have the obligation to report it to the regulatory agencies and all of that. So that's a lot of work. The last pillar, there are more information, instructions. You need to be very communicative with your customers, with the agencies. You need to be transparent. You need to show exactly like what your attack surface is, how you defend against it, what are your software components inside of your product. And this applies even if it's not online, as I said, if it's not connected to the internet, even if it has like whatever interface port or connector that allows the outside world to talk to play with your product, then you need to be compliant. And this in light with Debian in volume production, Debian being used on these devices, this also increases the problem because with Debian there's a whole lot of things that are very hard to implement that will be, or they are being mandated, right now. For example, secure boot is one of them. Debian makes it a little bit hard to implement secure boots, as we will discuss in the next couple of slides. Yeah. Cool. Yeah, so Drew, what's our solution for all of these issues?
Yeah, so we've got the solution called Torizon Connector, and as this graphic kind of shows, the idea is it's a mashup of a Debian style distro and Torizon. So you're not completely changing your operating system. You're not adopting the full Torizon OS, but you're installing some components into your system that give you access to some of the Torizon Cloud functionality. So the goal here is it's minimally invasive to your OS, right? If you're familiar with Torizon, you know that we've got OS tree in there that manages the versions and allows you to do the updates of the OS. That's a very invasive change, so that's not what we're doing here. So that we want to kind of hit the low hanging fruit, as they say, to give you access to some of the functionality of Torizon without a major shift in your development workflows and that kind of thing. Still based on all the Optane security that's built into the Torizon Cloud. So for those components that you are taking advantage of, you still get the security and peace of mind that comes with that Optane specification. And then obviously all the security and scalability that's built into the Torizon Cloud is part of this as well. And you can see, the logos on the bottom of the screen here. This is supported on a wide variety of devices. My demo today is on a Raspberry Pi because I have one, but we have customers using this on, just like I mentioned, x86 PCs and some other things, including some NVIDIA. I think it's there might be one or two users on like the NVIDIA Jetson family and that kind of thing. So that's really what it's intended to do. To give a little bit more detail, you get access to the device monitoring, remote access, OTA updates, and offline updates for applications. And in the Torizon terminology, an application is a Docker container, or our subsystems, which is just the custom payload type that you write a plugin for. So we do not support OS updates with this, but instead we rely on the package-based apt package system that's part of the Debian. But you could wrap the Debian packaging commands with a subsystem update, so that from the Torizon Cloud, for instance, you could trigger the device to actually go and do updates at a certain time and that kind of thing. So that can be done, but it's really intended to be the minimal change to your setup, but to give you as much functionality as we can without going in and completely changing everything that you're doing.
Yeah, I think this is the key point of the presentation here, right? With the Torizon Cloud, we try to solve all of these issues that we discussed regarding Debian, especially regarding like the management of your production fleet. So you have thousands of devices out there. With the Torizon Cloud and what it enables you to do, you will know exactly if the device is running or not, device metrics, if it's healthy or not, what version of the application is running. If you need to remotely log into it, you can easily do that with all of the security and reliability that Actualizer implements. I think we talk a lot about Actualizer here. Just to give our attendees some context, Actualizer is an implementation of Optane, which is itself a security standard that the automotive industry uses for OTA updates. That's all built into Torizon from day zero. So security is one of the pillars of Torizon, and yeah, that's everything that you get with the Torizon Cloud.
Yep. Yeah, very good. All right, so I guess it's time for me to step up here and actually show how some of this works. So the first thing I want to do is just show this. This is a web view of one of my Raspberry Pis, and this is just showing that my server is not already up and running. So I'm going to jump over to the Torizon Cloud. Now you see that I've got one Pi already baked and ready to go here. This is a Raspberry Pi 02W, and I went ahead and installed the Torizon the Torizon connector on it earlier, and I mainly wanted to be able to show the metrics. So we can see that the metrics are being gathered here. Just before we started, I ran a stress test to show the CPU usage spiking and that kind of thing. So, when you do this installation, you get this out of the box, and you get the kind of the generic fields, the memory usage, CPU usage, thermal information, things like that. But if you do have your own custom metrics that you want to plug in here, it's very easy to do that. This uses if you're not familiar, this uses a third-party open source tool called FluentBit, which is very easy to configure and plug in your own time series metrics so you can view them. Out of, like Lucas said, out of the box, we're looking for device health information here. In this case, it's a single device. If this CPU usage concerned me for whatever reason, I could access the device remotely, do some troubleshooting, look through logs and that kind of thing. But let's go ahead. This will take a minute, so we'll do this and then we'll come back. So I've got a second Raspberry Pi that I installed fresh just before we started here. And it really is as simple as copying and pasting this one command here. So now I've got that. Let's go to my terminal window, and this Raspberry Pi here, I don't even have Docker installed on it yet. This is freshly installed. So if I run that command, where's my paste? There it is. And this will take a minute. So we'll go ahead and get started and let this go, and then we'll talk about a few other things. But when you run this, it's obviously downloading this script from our server. And then it tells you basically what it's going to do. This is kind of what we already covered a little bit. So we'll go ahead and let this happen. It'll take a few minutes, and then it's going to prompt me for a little bit more information. But let's also do this. I did want to show, let's see, we talked about device monitoring. So obviously, the metrics is part of that. This whole dashboard is part of that, right? At the moment, we've only got the one device. But we also mentioned the idea of remote access. Now, this device is sitting on my desk. I can access it via SSH just over my local area network, and that's fine for development. But once my devices are in production and they're out of my control and they're at a customer site, I lose access to them. So we have our remote access feature that's part of the Torizon Cloud. We'll go ahead and create this. And what this is doing is allocating a port, in this case 4959, on our remote access server, which is hosted at, I believe, at AWS in Germany. And so now if I take this command and I go back to my terminal and I run this command, now this might be a little slow. It takes a minute before the device is actually accepting connections on this port. But what's happening here is I'm connecting to this port just using standard SSH, and then from the ras.torizon.io system, it's going down to the board, tunneled through the connection that the board has already maintained, that actualizer daemon that Lucas mentioned, that is maintained, the connection it maintains with the server. So this does not require an open port on the device, and it is able to get through firewalls as long as the device has TLS access to the Torizon server, then we're able to get access. So in this case, you see, it's not necessarily the fastest connection in the world. Not to mention, this is a Raspberry Pi 02W, so it's not the fastest device in the world. But once my devices are out in the field, I don't really have control over them, and this gives me that ability to access them. In this case, you see, it is Debian Trixie. It's the latest version of the Raspberry Pi OS. So that's the remote access feature. So we talked about device monitoring, the metrics and that kind of thing. So let's go ahead and see how our installation is going here. Okay, so it looks like it's completed. Now it's just going to ask me, it does create a user called Torizon, so I'm going to fill in my super secret password, and then the system is ready to pair with my account. And if you've used Torizon before, you're probably familiar with this. It's just the pairing code type application. So if we come over here and we'll just go directly to pair, and we enter in our new code, and so now that device has been associated with my account, and then in a moment that other device which is a Raspberry Pi 4. It's a little faster. Will show up in my account. I am going to cheat just a little bit, though. I've got a script over here on my other desktop system that changes the polling interval to make it a little bit better for demo purposes. So let me set that up real quick. Make sure that works. Looks good. Okay, so all my services have been restarted with the new polling intervals. And so now add myself to the Docker. If I can type, add myself to the Docker group. And now we see that, Docker is running, but we don't have anything going on. And if we take a look at the journal for Actualizer, we'll see that it is indeed talking about every 10 seconds to the server looking for update information. So now if we come back here, we see that this new device that was created, Blissful Sauce, I'm going to refresh just so we have the very latest on the screen here. It says it's up to date. If we click through, we look at packages. At the moment, it says there is no Docker Compose installed, which is to be expected. Same with the Cloud Connector. So let's go ahead and, of course, updates are the biggest thing, probably the biggest feature that people look at a system like this for. And we'll go ahead. I do have a package here. It's just a little web server that displays process information, container information, and that kind of thing. It's a fun little demo. It's the one that'll show up here on that web server. So we'll go ahead and schedule this. We'll start it immediately, and we'll initiate the update. So now the update is pending. If we go back to our server or to my command line here, we'll see that now there is a new update that's been found, and so this system will start downloading that Glances container. And in this case, I have a local shell on the device, but if this device was completely remote, then the same thing would happen. So it'll take a minute here for it to download. So in this case, if you're not familiar with the way the Torizon applications work, when we're talking about Docker applications, what we're actually delivering to the device is the Docker Compose file. So in this case, it's just a single Docker Compose that's starting up one container, giving it the various permissions it needs to be able to see the Docker containers that are running on the device, as well as all the processes on the device for what we're going to see here in a minute. So once it delivers this Docker Compose file, the device will then do a Docker Compose up, basically, which is going to go pull this image if it doesn't already have it, and we should have a container started. So I'm going to keep tap dancing here because it seems to be taking a while. But
hey, Drew, maybe a question from me. I see there in the logs, a whole bunch of signing verifications and hash checks and a bunch of what seems to be security stuff. What is Actualizer doing behind the scenes to guarantee that security and that reliability that we discussed about in the beginning?
Yeah, I mean, you basically hit it, right? This is all related to that Optane security model. All this root.json and things. There's a lot of metadata that the server keeps, right? We see this term repo metadata. If you want all the gory details, you can try to read through the Optane specification. I don't recommend it if you haven't had a lot of coffee recently. It is a typical security spec, so it's very verbose. But all this metadata basically is telling the device what are valid images and that kind of thing that it's able to download. We've got this I don't know how many bits this ECU ID is, right? This is the way that it's able to uniquely identify the boards and that kind of thing. So all of this is happening behind the scenes, but it is giving you all that detail and security that's available.
That's very cool. And this package that you are deploying to the board, this demo application is something that you push it to the Torizon Cloud. It's an application that you deploy there, and out of the box, it was signed with the correct credentials, and all of this was set up. Or did you have to do anything prior to that?
No, that's exactly it. I download, I use the Torizon Core Builder command. I download my credentials.zip file. So if you come down here, I think it's under repository information, and you can download your credentials, and then you provide that to the Torizon Core Builder command. When you do, it's Torizon Core Builder platform push is how you're pushing a new package, and that's how we got all of this this up here with all of the details, the hash, the package ID, all that kind of thing. And so so it looks like it did complete here. So let's go Docker PS just to verify. I do now have a container running, and if we go back to our web browser here, hopefully we'll see our glances view. It says it's Alpine Linux, and that's because it's actually in the container. The container is based on Alpine Linux, but in this way, I've actually deployed an application update to my device. And as far as the demo, that's basically it. Lucas, any questions before we move on from you, or anything relevant in the Q&A?
There's two things that come to mind. One is we talk a lot about reliability in the field. When you have these thousands of devices, you don't want to be managing, one by one, make sure that each one is running okay. So as far as I understand, with Actualizer and with the Torizon Cloud, you could have sent the same package to thousands of devices with the same number of clicks on our user interface, and it would handle all of the reliability aspects. So throughout the process that we saw there on the logs, if something was weird, if some hash didn't match, or if the power connection dropped, or if the network connection dropped mid-process, it would, again, out of the box, roll back to a previously working version, notify on the UI that the update was not successful for all of the boards because of reason XYZ. So this is all already implemented for us.
Yeah, exactly. That's the idea, right? With a fleet of one, this may be overkill. But when you're dealing with hundreds, or if you're lucky, thousands of devices in the field, the scalability is important. And then of course that rollback, because when you have that many devices, if something can go wrong, if you a 1 in a million chance is going to happen once a day if you have a million devices in the field. So definitely want to have that nice rollback capability. Out of the box, we have the obvious stuff. If the containers just crash and don't run, it'll roll back. But there's also some Docker health check mechanisms, standard Docker functionality that we just take advantage of, that you can implement a health check that would be specific to your application. If you wanted to, check the database sanity or something like that, something doesn't look good, you can force the system to roll back.
Cool. And maybe thinking of a little bit more advanced use cases. What happens if someone already has devices in the field running Debian? They might want to try it out, see how it looks, how it works. What's the recommended path?
Sure. You saw the way that it got installed there, right? As long as you've got a shell access to the device, even if they're in the field, you can install the Torizon Connector. So if you do already have a fleet of devices deployed, but you have some remote access capability, you can install the Torizon Connector that way. Otherwise, if you're starting fresh, of course, you can do it in your manufacturing, but it's designed to allow you to do that.
Yeah, and I see there the fourth step talks a little bit about containers. I think you were showing us the application update mechanism, which delivers containers to the edge devices, to our boards. Do I understand correctly that for people that already have a Debian system running today, we offer ready-to-use Debian containers with a whole bunch of packages, easy for them to use, so they can easily replicate their system as it is today inside the container and kind of deploy that through the Torizon Connector. Is that right?
Yeah, exactly. So that's one of the options, right? So if you've got a Debian system today, you've probably got your application built, maybe packaged as a apt package that you just install, natively in the host OS. But if you are moving to something like the Torizon Connector, one of your options would be take your application, move it into a container. Normally, if you're doing, like I guess traditional container work, it's focused more on the microservices, right? You break everything out into multiple containers. But if you've already got something working in a Debian system native to the, in bare metal on the hardware, you could actually just create a container that was essentially that setup. And then that gives you an artifact that you can upload to the Torizon Cloud and be able to deploy and update your application using this mechanism that I just demoed.
Cool, yeah. And I think you also mentioned in a couple of slides ago some limitations, for example, for OS updates, that it was not possible to do. I believe it relates to Torizon OS and the difference to Torizon OS to the Torizon Connector. What's Torizon OS, Drew?
Yeah, so this is where, we started Torizon to address those kinds of issues, as well as the complexity of building with something like a Yocto, which is what we have traditionally supported, right? And that requires our customers to basically become embedded Linux experts, and most of them don't have the time to do that. Even if they may have the skills to do it, they just want to start focusing on theirs. So the idea of Torizon beyond Debian is a couple things. One is a more robust ability to update that OS, right? Because it's a mutable system, because it's based on OS tree, and that allows us to get that atomic update capability. We can very closely monitor and match exactly what is on my test devices to what is on my customers' devices in the field. I don't have to worry about that package drift that you mentioned at the very beginning. So we get the full OS update capability. Does tend to scale better, just for all the reasons we've already discussed. And another important reason is the idea of that reduced attack surface, right? Debian is a full desktop distro. Even if you install it without the graphical user interface, in headless mode, it's still a fairly large system. And of course, the most secure software is the software that's not even installed. So with Torizon, we, instead of starting big and trying to strip things out, we start very small and add only those things that we need. And then we defer your applications primarily to the containers. So there are some benefits there. The downside, of course, is that it's a more invasive change to your system. So that's the Torizon Connector was really brought in to be kind of a bridge between these two worlds.
Cool. And I mean, what happens if someone decides midway to try to switch to Torizon OS, and they already have a fleet of the devices Torizon Connector?
And they will coexist for sure, right? You could have. I've got my Raspberry Pi. I don't have any Torizon devices in my account today, just because I'm always experimenting, cleaning up, and adding new things in. So before we started, I just cleaned out all the old devices. But I could easily have Torizon devices in there, and I could manage them just this, alongside the Debian based devices. And there's really no reason that I can't do that. I like the point on this slide about it does allow you to gradually transition, and that's the idea, right? You're not going to go in on one day and say, all right, I got 3,000 devices in the field, let's migrate them all today to Torizon. You're probably gonna stage that, get some feedback, make sure that everything's still working, and then eventually, if you decide you want to eventually migrate the entire fleet, that is an option. And that is something we have done for a couple of customers. They had a Debian system. We got them on the Torizon Connector. And then eventually we were able to work with them to, in the field, migrate the devices from the Debian-based system to the full Torizon system. So that's a bit trickier of a setup, but it is something we can certainly help you with. If you do have that need, we do have services that can help out with that.
Yeah, that's a very good segue to our next slide, which is our invitation to the attendees here to try it out for themselves. You can evaluate the Torizon Connector and the Torizon Cloud for free. Just go to Torizon.io. Hopefully you can find the Create Account button, and it's also some documentation on the Torizon Connector to get the one-line script that Drew ran on his Raspberry Pi to pair it to the Torizon Cloud. So then you can start to begin, those remote connection shells, deploying application updates, ingesting the device metrics, looking at all of that, creating maybe a fleet of a couple of devices. Besides trying it out for yourself, feel free to reach out to us in case you have, any sort of plans with migration. In case you already have a fleet of devices in the field running Debian, we are very interested to talk to you. You can also get a one-on-one call with Drew. He's our expert there, and I'm sure that he'll be very happy to help you out.
Yep, looking forward to it.
Cool, yeah, and with that, I believe we are ready to jump to the questions. So let me grab here. In the meantime, we got quite a few questions here. Let me do an initial triage. Okay, so this one is a slightly more technical one, but might be interesting. Why can we not do OS updates with the Torizon connector?
Well, I mean, technologically, we could implement something like that, but that's such an invasive change that it kind of goes against the design goal of Torizon Connector, right? This was supposed to be kind of the easy button if you've already got the system, we haven't gone so far as to making it a full OS update capability. Like I mentioned, you could use the subsystem update feature to essentially script around the APT updates. But if you're really looking to get into the more fully immutable, fully atomic system, we don't think Debian's the way to do that. We think that's just too much of an uphill climb for you.
Yeah, that's a good point. How hard it is to migrate from Debian with Torizon Connector to Torizon OS? I think we mentioned this throughout a little bit in terms of the containerization, but I'll leave it to you if there's anything more to add.
Yeah, I mean, it really depends on the complexity of your application, right? If you have fully migrated everything into Docker containers, then migrating to the full Torizon is probably a fairly modest effort. It's not going to be too crazy because all the complexity, or most of the complexity anyway, is going to be isolated to your applications. Now, you've got to figure out what components of the Debian system that your containers are taking advantage of and find the equivalents in Torizon and make some changes there. But if you've already done the work of containerizing, you've done the hard part for sure.
Yeah. How much will the install script change my system? What does it do exactly?
Yeah, it's actually very Debian-like what it does. We've got the remote access server, we got FluentBit, and we've got Actualizer, and they're all packaged as standard Debian packages. So they're installed, and as part of that installation, they install a systemd service that gets started and that kind of thing. So it's really not that different from any other package installation. It also will install Docker if it's not already there. So, again, that's the standard packages exist for these things. So it's, some config files, some services, and some Debian packages, and that's really about it.
Yep. Also, the user Torizon was created, I think, on your demo.
Oh, yeah, that's a good point. Yes. Yep.
Good. How does Torizon Connector solve the security front? It doesn't seem to add secure boot, for example. I think that's also a good question.
Yeah, correct. Secure boot is completely, orthogonal to this. The biggest problem with secure boot is that initial the root of the chain of trust is typically a very hardware-centric, hardware-specific thing. So, for instance, on our Toradex modules, there's a component in the NXP chips and in the TI chips that implements that initial bootloader signature verification, and it's very different from NXP and TI, and even in some of the NXP chips with other NXP chips, the mechanism there is a little different. Secure boot could possibly be implemented through the Torizon connector, but it's going to be done, specifically for, Raspberry Pi 5 or something like that. So it's not something that we can implement generically across the board. Some aspects of it can be more generic, but that initial root of trust is always going to be very dependent on the exact board and SoC you're using.
And I think you also bring a good point of the orthogonality of these things, because I mean, as we discussed in the very beginning of the webinar, Debian is very good for flexibility to giving you, those first couple of steps. You can make it very easy, whereas Secure Boot is on the other end of the spectrum, where it doesn't like things to change. You have your hashes, you have all of your assigned stuff, so they go in a little bit different directions, right?
Yeah, and if you are using Secure Boot and you want the full Secure Boot chain where you're verifying the bootloader, the kernel, the device trees, and the root file system, that's kind of incompatible with the Debian package model with a mutable system and installing all the packages. Yeah, you could probably make it work, but it feels to me like that's going to be a pretty heavy lift, and switching to an immutable system like Torizon with OS tree. That if that's your concern, I would certainly urge you to think long and hard about trying to do that on Debian.
Yep. Also another one, I think we mentioned it throughout, but maybe there's something to add. Does it support signed updates with rollback out of the box?
For the most part, yes. So for the Docker stuff, yes, definitely. The old versions are kept around. If if the new containers crash, it'll roll back to the previous ones. And like I mentioned, you can implement your own custom health checks for additional things that you might want to check. Subsystem updates have infrastructure for you to be able to implement the rollback yourself, but generally speaking, that's going to be dependent on the payload type. So, if you were implementing a custom subsystem update that, say, updates the firmware on a webcam or something, then it would be up to your scripting to keep the old version around and try to install the new version, and then figure out, whatever that makes it a failed update is going to be very specific to the payload type. So there's it's not something that you get for free, but the infrastructure is there to allow you to implement that.
Yep. Any specific version of Debian that needs to be running?
I've run it on both Bookworm and Trixie without any issues. I can't say that every single version will work, and obviously, as new things come out, we'll need to test them to make sure. But for the most part, it's implemented as standard Debian packages. So if there are issues, I would imagine they're minor and easily fixed.
Here I see a slightly larger question. Our product is sold to customers, and they will likely not be willing to give the kind of remote access to the device to us, the manufacturer, that you described with the Torizon Cloud. Privacy concerns may trump over security concerns. Are the features of the Torizon Cloud granular so that privacy concerns can be turned off while still submitting to security updates?
Yeah, absolutely. And that's not an uncommon thing, even for full Torizon users. We have a lot of customers that say, my customers don't want you to have remote access. Okay, turn that service off. Each one is a separate service. You can turn that off. You can turn off the Fluent bit if they don't want you getting the device metrics. The one thing that I skipped in the demo was the idea of offline updates, and this is kind of the magic USB key style. So you can even deploy this to devices that are not connected. You still have to use the Torizon tools, command line tools, and the Torizon platform to actually create the update media. But at the end of that process, basically you have the content for your update on a USB stick, and then the device itself does not need to connect to the service. It's just the operations team would need to do it, and that's a pretty common workflow for users where their customers are particularly worried about connecting to yet another SaaS service and that kind of thing. So you could create the updates and mail them a USB stick for the update, or they could do it themselves.
Yeah, and maybe going a little bit further too, there is also the possibility, for example, if the end customer wants to be very strict with who has access to their fleet, who has access to their boards, we have our API for the Torizon Cloud, so that you can create an abstraction layer with your business logic. So you have Torizon Cloud kind of guaranteeing the underlying security and all of the reliability, and then an additional layer with your specific business logic that further implements, more segmentation, more privacy, more granular access, depending on what you need and what your customer requires, right?
Yeah, for sure. Because most of the time, your customers don't care about Torizon or Toradex modules or Raspberry Pis or whatever, right? They're buying a device and they care about the functionality of that device. So, in the Torizon Cloud, there's a lot of information there that they probably have no interest in seeing. So, yeah, using that API to create a custom interface for your customers to get access to some subset of information is a fairly common approach.
And also a slightly related question here. So is there any type of customer-facing Torizon Cloud interface on the web for customer management of the remote access and security update schedule?
On the web, I don't believe so, but on the device itself, there is a dbus API that allows you to query some information about the update system, so that your business logic can do things like the mobile phone pop up that says, "Hey, there's an update available. Do you want to install it?" Right? That allows operators of the device to control when things happen on the device based on when the device is in operation and when it's not, and that kind of thing.
Yeah, I mean, on the web front, I think we just bring back again the API where you can build your own middleware, your own interface with your end customer, with your vocabulary and all of that. Yeah.
Right. And you can, we do have a scheduled update capability, but that's all on the server side. So that doesn't really get rid of the need to also have some business logic on the device itself, right? So you start the deployment, Saturday at midnight or whatever, but there's still plenty of need for the devices themselves to delay or reject updates depending on the state of the device and what's happening.
Yep. Question about hardware. So does this connector also work on an Intel processor?
Yeah, we've got some customers that are doing that. That basically they started with an Intel NUC or some kind of small form factor x86, grabbed the standard Debian ISO and installed it, and then realized some of the issues that we mentioned, and so they come to us, and we've used the Torizon Connector as for some customers they do the Torizon Connector, and that's all they need. But we've also used it as that bridge that I mentioned to get them halfway there while working on the full fleet migration to a full Torizon OS. And in case it wasn't obvious, we are starting to support Torizon, the full OS, on more than just Toradex hardware. So we do have builds for standard x86 PCs and a number of other ARM-based SPCs out there.
Yep, very good. Maybe the last one here, is it really free? What's included in the free tier? I think I can maybe start. So yeah, you can evaluate it for free. You can try it out. We are very open when people are trying it out. Torizon OS itself is open source. The connector as well. It's all on GitHub. You can find our method for the Torizon. You can connect it to the clouds. You can request a trial there and get access to all of the features. As you scale up, I believe, like in the number of devices, you would need to talk to our sales team to understand how it progresses depending on the amount of devices that you have. But yeah, the evaluation side of it's fully free and encouraged.
Yeah, and just to add a little bit, all of the device side stuff, there's no charge for that, right? It's only when you start actually using the cloud stuff, in volume and at scale is when the pricing comes in.
Yep. Okay, yeah, I believe with that we are pretty much done. So yeah, thanks Drew once again for being here for the presentation, for the very good demo. Thanks to all of the attendees. Again, the recording will be made available for later on-demand viewing. And yeah, thanks everyone. Have a good rest of the day.
Yep, thanks, and thank you as well, Lucas.
Absolutely. Bye-bye.